navigate that at night.
I think we should try it. I don't want to test them right now.
Yeah, I guess we should try this.
We should maybe after class. All
right, good morning, everybody. We're gonna go ahead and get this started. My name's Leo. We'll be going over the TXVs. I know there's many different types out there. We're just going to briefly touch up on these so everybody's familiar with the operation of the TXV. So TXV is a metering device that regulates how much refrigerant enters the evaporator. Commonly used are cap tubes, TXVs, and single orifice opening orifices. The metering device tries to maintain the preset temperature difference or a superheat between the inlet and outlet openings of the evaporator. As a metering device, regulates the amount of refrigerant going into the evaporator. The device lets a small amount of refrigerant out into the line and loosens the high pressure that was behind it. Just keep it in mind, it's still in a liquid form. Now we have a low pressure, cooler liquid refrigerant entering the evaporator. Pressure went down, so temperature goes up. At this time, it's boiling the refrigerant, absorbing the latent heat. Here's a little example of exactly what's going on here with the TXV. TXVs and TEVs are exact same thing, just different.
Any reason people would call it TXV or TEV, or just purely?
Just purely
names. Preference.
Yeah. Some manufacturers call it TEVs, some manufacturers call it TXVs. Older service techs still call them TEVs. I've been brought up just calling them TXVs. Yeah, they operate the exact same way.
It's a way of abbreviating expansion.
Exactly.
X.
Exactly. A very common type of a metering device is called a TX valve. This valve has the capability of controlling the refrigerant flow. The TXV has a sensing bulb attached to the outlet of the evaporator. This bulb senses the suction line temperature and sends a signal to the TXV, allowing it to adjust the flow rate. This is important because if not all, the refrigerant in the evaporator changes the state into a gas. This could be a liquid refrigerant content returning to the compressor. This can be fatal to the compressor. It'll knock out valve plates, your leaf springs, washes the oil out, it fries your cylinders. It could be a nightmare. So we've got to make sure we've got a good superheat, maintain really good superheat to cool down the compressors, especially in the summertime. This could be, liquid cannot be compressed, and when a compressor tries to compress a liquid, mechanical failing happens. The compressor can suffer mechanical damage in valves, bearings. This is called liquid sludging. And now on some of these compressors, like a 3D, you'll see if you look in the oil sight glass, you'll actually see liquid boiling inside the oil if you're getting flood back. So that's something to kind of keep an eye on. Just because you got frost on the suction valve of your compressor doesn't mean you're getting too much liquid back. I would just keep an eye on the oil. And if you see any bubbles in there, you might want to throttle some of your TXVs down, see what's going on. Normal TXVs are set to maintain 10 degrees of superheat. That means the gas returning to the compressor is at least 10 degrees away from the risk of having any liquid.
Is 10 degrees pretty normal, Leo? Do you see some manufacturers recommend?
It's pretty much customer. Most people like between medium temps, usually I believe it's 8 to 10, and then your low temps run a little colder, which you'd like to see 4 to 6. If you do a Walmart's, they like to see the 2-degree superheat. They like to run theirs just really cold. They got the different type of compressors. They got Carlisle's, so they tend to take the liquid sludging a little better than the Copeland's in my past experience. So here's kind of the components of your TXV. You got your power head, obviously your inlet and outlet. That 1/4-inch line is your equalizing line. If you don't have that, it's usually internally equalized. What that does is once that pressure builds up in that power head, that pressure's got to go somewhere. If it doesn't, those push rods are not going to operate correctly. So when you go from an internal to an external, we got to make sure we take that equalizing line, and it has to be in the suction line downstream from the TXV. You don't want to put it between the evaporator and the TXV. It just defeats the purpose. You're going to have a higher warmer where the bulb's at. Another thing, you got your springs, you got your guide spring, your adjusting stem. That's just pushing the spring, giving a little more tension on your push rods, so it takes more pressure to push that down.
It's just zooming in on the top half there.
What was that?
That's just zooming in, I think,
of
the
okay.
zoomed in views. So it's easier to see.
Now, one thing with the power heads is they are charged with gas. It's usually a mixed blend. That's why you have a 404 power head. Usually it's compatible with 404 gas. R22 407A, you'll have a green label, and that's compatible with just that refrigerant. So when you change power heads, we got to make sure we're putting the right ones in.
They're pretty much on label, right?
Yeah. Yeah, and if you're missing a tag, it'll have numbers on it. Later, further down, it'll show you what the numbers mean. We'll get there in a second. What types of equipment use TXVs? Basically, nowadays everything's using TXVs except for your refrigerators using your cap tubes, and Sportland's one of the major brands. Emerson, you got Danfoss out there now. I prefer Sportland. Danfoss are kind of tricky.
And would you recommend any of the particular brands, or does it depend on the equipment you're using?
It just depends what equipment they're using. They usually ship them already by replace, part for part. If they got a Danfoss in, I'll put a Danfoss in. I think Sportlands are a little more easier to work on. Like if you have a Danfoss valve and you take the screen out, there's a metal O-ring on there, and you have to replace that O-ring. Every time you open that up, you have to replace that O-ring. And a lot of techs don't carry those O-rings. That's why I really don't care for Danfoss. It's not a rubber O-ring. You can't just put a rubber one in. It has to be a metal O-ring, and it will leak.
Are the TXVs physically located inside the equipment? Like
yes.
Inside the case itself instead of up on the compressor?
Yes, they are located as close to the evaporator as possible.
We'll show that here, I think, in a
yes.
second. Good question.
So here's kind of a little diagram. It's really not sure what it's showing.
You can click, bring some text on.
See, here you go. TXV should be installed as close to the evaporator as possible and are mounted in a vertical upright position, which 9 times out of 10, they're not vertically upright. They're on their sides because of the spacing, especially you get a multi-deck case or a seafood case, they're on their sides.
Does that affect performance much?
They say it does, but if it really made a big difference, I don't think they'd allow manufacturers doing it. I mean, they say it has something to do with the liquid, yeah, just settling inside there. TXV and the evaporator are located above the receiver will cause a vertical lift and may cause a flash gas. Typically, if it is above the receiver, before it even goes into the receiver, most compressors will have a crankcase heater, and whatever liquid goes back that way is going to get boiled off in that process of compressing the vapor into high pressure vapor. You won't really run into these kind of problems, not in the grocery store side anyways.
Another time for training? Yes.
When soldering, make sure the direct frame is away from the TXV. A wet cloth may be placed on the TXV as precaution. I recommend wrapping it every time you put a torch near it. Those push rods have oil from the manufacturer, and heat and oil, they'll dry up. Those push rods will start sticking. You're just going to cause trouble. Now, I know Danfoss says you don't have to do theirs because theirs is a thin stainless metal, and it doesn't take as much heat as these sport ones do, but I still recommend wrapping every valve whenever you got a torch near it. And you want to keep away from the bulb because those are pressurized and they will explode. I've seen it, and it's like an M80 going off in a case. So they're pretty loud and they're scary. So make sure we keep the bulb out of the way of the flames. I mean, they're 4 or 5 foot cap tubes, so we can just bend it and pull it out of the way when you're changing them out. If I'm changing out a valve, I'll just grab my dikes, cut the cap tube off it, then I don't have to worry about it. But I've seen it knock people's glasses off their heads, and it's pretty intense.
So be safe, and it just takes 30 seconds to wrap it, right?
Exactly.
And then avoid that cap tube.
Yes.
And apparently ensure you're wearing eye protection too.
Yes. We went over this yesterday. It's very important when you're doing your location of the bulb. Make sure at 2 and 10. You want to make sure you're getting nothing but vapor. Obviously, if you put it towards the bottom, you could have a little bit of liquid down there. There's going to be oil on the bottom of your suction line, so that's going to affect the operation of your TXV. So you want the bulb to be between 2 and 10 o'clock. I know some of these cases nowadays, the higher performance cases, your suction line's only a 5/8 line. Obviously, you're going to put it right on the side. I mean, there's really no place to really put those. So, but that's why they have more than one TXV in a case nowadays too. The bulb should be attached to a horizontal suction line, and the evaporator outlet should have a good thermal contact. You want to avoid strapping that bulb on welds. So whenever you're piping like a walk-in coil or anything like that, what my rule of thumb to the guys I teach is when it's coming on the outlet of the coil, 6-inch piece, then your P-trap. That bulb will mount just right between that P-trap and the outlet of that coil. If not, you won't get good contact. Some people like put big shoulders on their welds. That's why I always say 6 inches, and you'll see daylight. If you shine a flashlight through the bulb, you see daylight. It's not a good contact. You also want to make sure there's no debris between that bulb and the suction line. I mean, if you're putting a brand new TXV in this old equipment and it's all green from the copper, take a piece of sand cloth, let's clean it up, strap it, make sure it's got good and tight, and it'll work great.
Is there another option to put it when there's not 6 inches between the feed truck and then the outlet of the evaporator?
It's close. Find the closest place to the evaporator. I've seen them mount them on the rise on the coil that your passes are going through your suction line. It's not a very good place to put them. I've seen them on the riser of the suction line. Once again, it's not a very good place. I mean, it's pretty much a bad install if somebody really do that correct. And see, that's another thing with Danfoss. I don't have a Danfoss valve, but their bulbs are half the size of a Sporlan. So an option would be putting a Danfoss valve in.
So the smaller.
Yeah.
Bit.
Yeah. I think their bulbs are like 2 inches. Where
Stainless steel
yeah. And where Sporlan's 3-inch bulb.
requires a lot more.
Yeah. So that's when I tell the install guys, at least 6 inches, because you're avoiding the welds and there's no problems. The bulb should never be located in a trap or downstream from a trap. We just went over that. Like I said, I would totally just try to get as close as you can to that coil. On the riser, you're getting oil that's going up in there, so it's going to throw that temperature off just a bit. I mean, I don't think it's going to affect it too bad, but it will affect it. Now we're going to go over superheats. I know a lot of techs nowadays use their fancy gauges, smartphones, but here's a diagram on how to do it the old school way. It's good to know sometimes. I mean, you're out there middle of nowhere, and I know a lot of people can't afford those fancy gauges that do the superheat for you. Yeah. And also, when you're out in the middle of Wyoming, phone service sucks. You don't have Google. So it doesn't hurt to know that the old-fashioned way. I still use it this way because altitude, some phones and stuff like that, smart apps, you can't take into altitude consideration. A lot of people say there's not that big of a difference, but it is quite a bit of difference. If you take below 5,000 feet and compare it to above 5,000 feet, you'll see there's a 3-4 degree difference, especially the lower temperature you go. So you obtain the suction pressure at the suction line. Now, 9 times out of 10, the evaporator coil will have a port where you can hook your gauge up, take your suction pressure right as close as you can to that bulb. You want to take your PT chart. So if you've got, it says right here, you've got, 40 degrees. Once you convert it, and then you're subtracting that from your suction line temperature, and that'll give you your superheat. Obviously, if they're 12 degrees superheat, on the example they're showing, just make sure you're doing the right gas. That's another big thing. Make sure you're not. I know those PT charts can be confusing. You're going down, especially if you go in lower temperatures like -10, -15. You're scrolling all the way down. I just kind of make sure you're doing the right one.
Do they put the superheat on a nomenclature plate? Is it written on there? I mean, you've got the refrigerant and all that on there and stuff. Do they put the
Yes,
superheat on
this is actually on there too. This little exact same picture is on all the
I
charts.
think he's asking on the nameplate.
Yeah, on the
serial
nameplate,
number.
Oh, no, sorry.
Pretty rarely you'll see it. I think the only cases that I've seen is Southern K-Guards. I've seen them that one of them have the required superheat on it.
Yeah, I mean,
Typically, it's not on there.
the literature books that come with the cases will say in there, but typically when you're doing an install and setting superheats to manufacture, that's just a recommendation.
Sure.
The customer wants it set a certain way. Just like yesterday, I know Jim was going over it. He likes to see a 4 to 6 degree superheat, and I explained to him Walmart specs 2 degree. And if a technician comes in, a Walmart tech comes in and says, hey, you got a 6 degree superheat, you need to come back, it's just kind of a wasted trip. So you got to make sure you read your customer spec books and go from there.
So Leo, here in the picture, maybe for those that are looking at step 1, measure the temperature of the suction line of the bulb. That's the 52 degrees right there, right?
Yes.
And then step 2, you're going to take the suction pressure. That's the 68 PSIG, right?
Yes.
You use the PT chart, and the 68 pressure translates to 40 degrees temperature, right?
Yes.
Then you're just subtracting.
Yes, and that's
your
superheat.
Okay.
Now, if you wanted a 10 degree superheat, obviously you're going to back out the stem to feed more refrigerant in. And I'll give you a colder suction line.
It'll adjust from there.
It adjusts from there.
On the TXV.
On the TXV.
That's the stem.
That's the stem right here. So this stem here, if you want, you lower your superheat, you run out. And if you want to go from 12 to 14 degrees, you run it in.
So
now these things,
more gas is colder, less gas is.
yes. Now the thing is, you don't want to give it a big crank because these things are sensitive. What I typically run into, usually a quarter turn to a half turn is usually about 1 to 2 degrees. So you want to be really touchy on these. I mean, it varies from valve to valve, but typically it's 1 to 2.
How long after making an adjustment, how long
You'll
see that in the superheat if you were to measure again?
Okay, when you make your first adjustment, I usually watch it run through at least 2 cycles on your temperature. You'll see that, they call it hunting. You'll see your temperature go from 52 degrees down to, let's say, 44 degrees. Then it'll go up to like 60 degrees. And that's when we were talking yesterday also, you're taking that average. So if it's 60 and 42, that average is where they're getting the 52 degrees. So typically you want to wait at least two cycles, because you'll see it once you open up that valve, it'll drop down lower, maybe 1 or 2 degrees. Then it'll go up, not as high as the first time. And the second time, all of a sudden, that thing will just slam down on you. So you got to be really patient with superheats. I mean, it can take you 15, 20 minutes to set one valve.
Okay.
So just got to be patient. You got to watch, go through its cycle.
Be sensitive with those adjustments.
Yes.
A small adjustment can lead to a big swing.
Typically, a good starting point if you're doing a new install, I've learned over the years, and I've had a lot of older guys show me, you run it all the way in and back out 3.5 turns, and that's a good starting point. Typically, that's usually what a good starting point would be. And once you let that run for a little while, I've got a Cooper thermometer, and I can do 2 TXVs at the same time. So I'll adjust one, then I'll go watch this other one. Then when I watch this one go, I'll make my valve adjustments, and then I'll go back to the first one. Then I make, once I get them tuned in, then you go from there. Then you can just leapfrog, do 2 at a time.
Usually, what does it mean when your TSV is hunting a lot? It's doing a big swing?
Yeah, that could be several things. You'd be low on gas.
We've got a slide on that coming up on hunting.
Yeah.
Yeah.
So, okay, we already went over that. So here you go. Starved evaporator means a high superheat. Flood evaporator, low superheat. When you're flooding your evaporator, that liquid's going to go back to your compressor, sludge, wash the oil out. Typically, like if you have an oil fail, it's more than likely is because you got flood back. To increase superheat, turn the adjusting stem clockwise. Now, it gets kind of confusing whether, laying that out is to increase superheat. Increases making your superheat go up. So you're going from 12 to 14. You're on your clockwise is which you run that stem in. So some people get confused on that part. Yep. To reduce superheat, which is colder, turn the adjusting stem counterclockwise. When adjusting the valve, make no more than one turn at a time and observe the change closely. You may need up to 30 minutes to observe the effect of a full turn valve. That's why I say do a quarter to a half at a time. It is pretty time consuming, but it saves a lot of service calls. Yes. So look at your manufacturer specs for recommended superheat levels. Like, once again, that's the guideline. I definitely go to your specs. I know a lot of these, I know Core's got their 4 to 6 and 8 to 10. That's pretty much standard across the board, but just double check. I know a lot of literature gets thrown away after installs, so a lot of techs go out there blind, and it is good to go, 4 to 6, 8 to 10. Over the years, you'll get comfortable with where it needs to be. Superheat hunting is a cycle function of a superheat caused by excessive opening and closing the TXV. So that sweet spot you want in the middle, and that thing's just going up and down, up and down, up and down. And you'll see on your temperature probe, you'll see it go from 60 degrees all the way to 20 degrees, back up to 6 degrees, all the way to 18 degrees. It's just going crazy. And you can hear the valve feeding. It takes a while for it to calm down, and you'll see a tighter group of your temperatures. Your suction pressure is basically going to stay the same. The only time that's really going to affect the difference of the suction pressure is if a compressor kicks on. You're going to get more velocity suction back to your compressors. So once I gauge up, I just keep that one number constant straight across the board.
And give the temperature some time to normalize.
Yep. Your suction pressure, basically, it's only going to adjust a couple of degrees, pounds. That's not going to affect your superheat, really. You just want to make sure you keep an eye on that temperature. Common causes of hunting, if it's still doing that, it could be an oversized valve, undercharged system. Check your bulb contact, imbalanced heat exchanger. That you only see that on a parallel racks. On the most of like the Mavericks and stuff, you won't have a heat exchangers. Potential fixes: you examine the airflow and circuits to ensure consistency. Adjust superheat slightly higher, move the bulb further downstream. So I know that reminds me of some of them Sporland valves, non-adjustable. If you get those and you got a really low superheat, like you're getting flood back, take that bulb, move it downstream, further away so it warms up. Me personally, if I have a problem with it, I'm cutting it out and putting an adjustable TXV in. Those non-adjustable ones they're pretty tough.
I've seen that happen in some of the calls.
Yeah.
Well, they'll do that, yeah.
So I recommend just cutting it out, putting it. But to get you by, you can slide that bulb down further. There's really not much you can do with those non-adjustable TXVs. I don't know why.
Why would you even make those?
It's a Hussman deal. I think Hussman's the one that, yeah. And I know.
Follow the money.
Yeah.
Exactly.
Like airflow, that will affect your superheat. So make sure you got good airflow. Make sure a lot of problems with, people check the honeycombs, obviously. Also check your fan blades. I mean, a lot of dirt and debris that get stuck. I mean, I've seen it, and that slows down your fan motor, eventually burns it out. So kind of just take a brush, clean off your fan blades. Nowadays, they have fan guards over the fan blades too for safety. Those things will get plugged up, clean those off. I don't know if a lot of the service guys know this or not, but there is baffles in the back of cases or up on top before the honeycomb. And what those are is just a piece of metal with a bunch of little holes in it, and those will get plugged up. So you want to keep an eye on that. Mirror, flashlight, see if there's any expanded metal in there with holes in it, and if it's plugged up, they suck to clean. The older Hill Phoenix cases will have them in the back of the coil, and that's just to distribute the air, and they will plug up, and they're not very easy to clean. So if you got a plugged up honeycomb, more than likely you got plugged up baffles.
Have you seen on the supermarket cases, the place where they get flattened out?
Yes.
Do you know why?
Product.
Mm-hmm. They get hit. We've seen that a lot of vehicles.
Yep.
We
Product.
into blades that are almost flat.
You're talking fan blades?
Yeah.
Yep. What they're doing is, I've learned over the years too, on something like that, they're taking, like, let's say just a packaged deli case, and all of a sudden, okay, we'll make it a beverage case. So they're putting all that weight, and that grate that the product sits on is not designed to hold 200 pounds of weight. So it pushes down. Or when they clean cases, they don't install the grate correctly. It hits the back holes, but not the front holes. So it's sitting on the coil. Put the product in, it pushes that drain pan down, and it smashes down. There's a lot of, usually it's store related. Mostly it's over stocked. Complaint A. So this is a problem you can run into TXV problems. Valve does not feed enough refrigerant. Symptoms are going to be low temperature, superheat too high, suction pressure lower than normal with compressor unloaders locked out or hot gas bypass shut off. The valve feeds too much. Liquid returns to the compressor, you get sludge, washed your oil out, cylinders go out, leaf spring goes out. Usually when you have something like that, hopefully the oil fell. That's why I recommend never jumping out oil fells. I mean, not even for a night. Wake up the parts store, I'd go get one. I mean, that's pretty critical, is not to jump one of those out. System won't perform properly. If you can't get your valve to do anything, what I recommend is taking the bulb out, holding your hand, because you'll hear that feed. If it's not feeding, if you don't hear anything feeding, pump it down. Check the screen, make sure it's not plugged. Do not make any valve adjustments. If you had a good startup guy, you should never ever have to touch that TXV adjustments. Usually it's something else. I'm not saying it does happen, but some startup guys don't do a quality work, but you shouldn't hardly ever have to adjust that TXV once it's set from start. Usually you got a plug screen, bag power head, excess heat. When they put it in, these pins will get stuck. What I've done, I take what I carry in my pouch. It's just an example. The acid test valve. Once I find an empty one, I fill it up with oil, just refrigerant oil, and I put it in my tool pouch. I mean, 9 times out of 10, you're looking for oil to lube an O-ring up or whatever, and it's always in my pouch. It's pretty small, compact. It's pretty handy, actually. I've pulled those pins out. I've lubed them up. When you're trying to pull them out, you can feel it sticking to the sides. Just lube those up. If that doesn't work, replace the valve, and then obviously you'll have to redo superheats. EEVs, electronic expansion valves. They perform the same function as a TXV, but operates electronically by relying on a sensor and a controller. How does an EEV control refrigerant flow? Exactly same way as TXV. It's got a transducer that reads your suction pressure, and once that it calls for it, it's almost like a stepper valve. It starts to open up a little bit and feeds refrigerant in.
Is it safe to say that EEVs are more reliable than thermostatic?
They are, but they are a lot more expensive.
More expensive, yeah.
They are more reliable. Usually when I have a problem with an EEV sticking, I power cycle it, and it seems to take care of it. And they are reliable, but like I said, customers don't like to see that bill.
Do we see more TXVs or EEVs out?
The newer grocery stores, you're going to see more EEVs. It seems like a lot of them are going to that. A lot of the Smiths, Wincos are starting to go to them. They're just more reliable.
They're starting to be a little bit cheaper, right? I mean,
they're coming down in price, but there's still a lot of work. I mean, you can't just change out one of these and put an EEV in.
Yeah.
You know, I mean, it's got to have controllers. You have to have transducers. So there's quite a bit of more electronics involved, but they are more reliable.
And the tech doesn't need to deal with the superheat because it's taken care of. Right?
Yes, yes.
So it's tech friendly.
Yep, it's definitely tech friendly. They're set for manufacture in the programming. You can go in there and adjust it on the Emerson. You can go in there and adjust your superheats. The controller, you can go in there and tell it what you want the superheat to be. They're nice.
Most of the EEVs will come with the display.
Yes.
You can see your actual superheat.
Yes.
On it, what it's doing.
Yep.
It's just light feedback.
Yep.
Right from the source.
Nice.
It is nice, but it makes us techs lazy. I think that's it.
So questions, I think most people that aren't here in Salt Lake are on mute. So if you do have a question, now's the time, but make sure to take yourself off mute before asking. Otherwise, your question will not be heard. I also know Jim's been got a little chat. He's been sending a few notes as Leo's been teaching on the Zoom chat. If you have that pulled up as well, feel free to read through those.
Dave, this is Sean up in Idaho Falls. I think it's probably important to point out, Jim and I have been chatting a little bit too, but I think it's important to point out when adjusting an expansion valve is to do so when the case or the box is close to the design temperature, not directly on startup if it's a warm box.
Absolutely.
Can you repeat that, Leo?
You're totally correct on that. When you're setting a superheat, obviously you want to have a load on that. You want to have it down running for a few days. When I went to school, they gave us a test on superheats, and I bet you 9 out of 10 techs failed. They had a couple cases running, and everybody set their superheats. And the ones that had product in there passed, and the ones that set superheats with no product in there failed. It does affect. You need to have some kind of heat exchange. That's a good point.
Well, that does make sense. If you have a call and someone where they adjust the superheat and then they have to go back.
And I failed, by the way.
Also, open cases, you gotta have your panels on.
Yes.
Or your airflow.
Yes. And like I said, I mean, you can get it close without product, but usually when I'm doing a startup on a brand new store, I'll set it with no product in there, and then once they start putting product in there, I always tell the store management to leave the bottom section where the TXVs are at. Then I'll go back and make my adjustments there. Yes, but without product, you'll still get it close, but you won't be on. And then also with like a Walmart deal, they like to see their case temperatures within 2 degrees of each other. So you set your superheats, and one will be 4 degrees off.
Yep.
And to me, I don't know, if they want the 2 degree superheat, you're going to adjust that superheat to get those temperatures the same.
So when you have a bunch of sensors, you're seeing temperature difference on them.
Yes.
Usually it's your superheat.
Yes. But usually when you have something like that, they have multiple TXVs in them cases also. So, any more questions?
Jim's kind of chimed in on it a little bit. We've been talking bulb placement. As far as bulb placement goes, the 10 and 2 is effective for smaller diameter pipe, whereas once we start getting 7/8 and larger, we actually need to position that bulb lower so that we don't allow that basically the space at the bottom of the pipe to fill with liquid.
Right.
We want it high enough
4 and
that,
7.
yep, high enough that we're not worried about the little bit of oil that's in the bottom of that suction line, but we don't want to be too high as to allow liquid refrigerant to sneak by the bulb underneath.
Yeah, I just said the reason I said 2 and 10 was because most stuff you guys are working on right now is the smaller pipe. My suggestion is when you're mounting the bulb, it comes with the package slip, and you can read the directions on there and see where, you know, on the bigger pipe, obviously, I will always mount mine at 4 and 7.
Looks like Jim also chimed in on pressure drop across the expansion valve, or the required pressure drop across an expansion valve for proper feeding.
I can't hear. Can you hear him? I'm sorry, I can't hear you.
Nope, sorry. Jim kind of chimed in to discuss a little bit, if we can, on the required pressure drop across the expansion valve for proper feeding.
I have to look that up. Let me see. I don't know if Jim knows it off the top of his head.
I think he's on a plane, so.
We can hit that up later on these next couple classes. I'll look that up and let you guys know what the pressure drop is. I mean, obviously it's gonna change from a internal equalizing and an external.
Can you hear me?
I hear you a little bit now.
Yes. So your pressure drop needs to be about between 100 and 120 is what Sportland likes to see across that valve. So that's why I wanted to bring that up this time of year, is because with low ambient controls being in play, we want to make sure we're getting that 100, that's on a 40-degree box at R22. So depending on your refrigerant and stuff, just make sure you're checking your headmaster, but you want a significant pressure drop to the tune of 100 PSI across that valve from high side to low side. So just make sure that you're getting a good pressure across that valve. If you're dropping your ambient too low, that valve's not going to feed. It's also going to cause adiabatic expansion to happen in the line on the way down to the cooler and lower ambient conditions.
Yeah, that's a good point. All right, guys. Well, appreciate your time. Have a good morning and be safe out there.
So upper left, top there, go to stop share, that red one. And then the bottom red and B.
Thank you.
Yeah.
So go down.
Yes.
Oh, there it is.
Yeah. And maybe.
Yep.